So today is Jeremy Vetter, who is an associate professor at the University of Arizona. And we actually met, I was thinking about this, in 2006. When we were both, we were both in Berlin. And I think we met maybe when we got in like an argument with my office mate, Rodri. I don't know. He was very argumentative.
Rodri?
Yeah. What became of Rodri?
Where did we go with it?
Jeremy is at the University of Arizona, though, as an associate professor of history. He got his PhD at Penn in 2005. He worked with Robert Kohler, whose work I'm sure a lot of you are quite familiar with, and I think Jeremy has sort of carried the Kohler banner forward in new and interesting ways. He works much more closely on the field sciences. Has also been at the forefront, I think, of this move within environmental history and history of science to look at the sort of conception of the globe, I guess, of the sort of global orientation of science that comes into existence in the 20th century. What else do I have here? That he's certainly, I think, pushing at the intersection of history of science and environmental history and how there's sort of this co-development of these projects along with economic development and sort of shifts in the environment, environmental transformation. He's, I think, certainly known within the field as a great collaborator. So you see this in the co-editing and co-authoring and co-workshop organizing that he's known for. He's got a bunch of books in progress, I was noticing on your CV. And one
Did you get that off of the department website?
Yeah, there's like 5 in progress.
For the first time ever, I decided to post my CV, and I'm wondering if anybody would ever find it there.
I looked at it.
So now
there's a wealth of information on there.
I never used to do that until a few months ago. And somebody was asking for it, I'll just put it up there so everybody can find it.
It was super helpful.
It worked.
Yeah. That wasn't even me, so there were at least 2 people. Today he's going to talk about his most recent book that is out in material form here and also Kindle. So Field Life Science in the American West during the Railroad Era. So thank you, Jeremy, for joining us.
All right, well, thank you very much for inviting me here. It turns out that I think I was actually chatting with Mark Hersey, who's unfortunately not here this semester, about the fact that I was about to come through this part of the country. And so I think he alerted Alex to the fact that I was coming through. It turns out one of my strangest hobbies that I developed when I was in graduate school was driving U.S. highway numbers from one end to the other. So say U.S. Highway 50 from one coast to the other. Well, it turns out I've never done U.S. Highway 82 before, which goes right through Starkville. So it's perfect. And I've always been a little reluctant to do US 82 in the summertime because it's so hot down here. And I thought, well, but I'm on leave this semester. I can go in April. It'll be perfect. And I can go up to Chicago for the environmental history meeting. So I'm in the midst of driving US Highway 82. Have any of you ever been curious about where it starts and ends? US Highway 82? Any guesses?
Where do you consider the start, the west or the east?
Well, either one. I'm doing this one west to east because I start in Arizona. But does anybody have any guesses where US 82 starts or ends? In Georgia? It does end in Georgia or start, depending on which way you go, in Brunswick, Georgia, near St. Simon's Island, the town of Brunswick on the coast of Georgia. That's where I'll end up. And it starts in Alamogordo, New Mexico. So that's the road I'm following. But I've always wanted to get to Starkville, to Mississippi State, because this is one of the schools in the country that happens to have an intersection of nearly all of my fields. So I started out as a historian of science at Penn. As Alex mentioned, my PhD is in history and sociology of science at Penn, but I gravitated very strongly while in graduate school towards environmental history. And then the more I got into my project, the more I also got into agricultural history, because it turns out, if you look at the field sciences in the American West, especially on the Great Plains, during the railroad era, a lot of it was agricultural science. That accounts for both through the United States Department of Agriculture and also through the state experiment stations, accounts for a fairly significant proportion of the science that was being done. So I became, along the way, also an agricultural historian. And of course, this is a place where agricultural history, environmental history, the history of science and technology are all cultivated all together. So it's one of those rare places in the country where I have a lot of colleagues. Just about every meeting I go to HSS, I see some people here at HSS. I see other people at the Ag History Society or at the ASEH for environmental history. I guess the only one not so much is Western history. This is more Southern regionalism here. But I'm also a Western historian of the American West. So that's the other group I relate to, is the Western historians. but it's great to be at a place where I have so many different audiences. So just out of curiosity, how many of you consider yourselves to be historians of science and technology? How many of you consider yourselves to be environmental historians? You can raise your hand as many times as you want to. How many of you consider yourself agricultural historians? Okay, so we have some of all those. Any Western historians of the American West? One. We got one over here. All right. So I have a lot of audiences here. So it's a place I've always wanted to come because this is a place that like me, is situated at the intersection of all these related fields. So what I want to do today is I want to give you a brief overview of my new book, Field Life, Science in the American West During the Railroad Era, which was just published last fall. And I want to go through a little bit of the backstory to this book, give you a little bit of the background details that you might not learn just from reading it, but also to summarize what I see, what I want to be some of the major takeaway points from the book, how I organized it, what are the main themes I wanted to emphasize in writing the book, and then hopefully when we have questions and answers, if you want to probe me any further on any of those things, you will feel at that time you can do that, and we can engage in kind of a dialogue. Now this is sort of the opposite of a works in progress because it's already printed, so it's too late to influence the book itself, but hopefully the work that I do going forward, the work that other people do, debating with this book or engaging with it in some way, agree or disagree with it, will proceed from the kinds of conversations that we can have here together and later. So this is really a kind of it's something that's been fixed in print now, so it's no longer a work in progress, but I think there's a lot that could still be debated going forward about the many issues that I'm trying to raise in this book. Most fundamentally, what I am trying to do as a historian of science for now is to take the turn towards the history of scientific practice even farther than people have taken it in the past. So one of the major developments in the historiography of science in the latter part of the 20th century, especially in the 1990s, was a turn towards practice, that we're interested not just in what scientists are thinking, not just a history of their ideas, but a history of their practices. This was partly an outgrowth of the more general social and cultural turn towards social constructivism, but in the 90s people took this even further to emphasize, well, what were scientists actually doing? Not just what were they thinking, what were their ideas, but what were they actually doing on the ground? And what I was trying to do to take that practice turn further in writing this book was to imagine, what if we took it so far that we went into environmental history? So we're not just interested in the history of the environmental sciences, that is to say, in the history of how people have thought about the environment, but in the environmental history of science itself. So in the ways that the environment, the natural environment, shaped the practice of science. And in principle, that would not be in any way restricted to just the environmental sciences. You could have an environmental history of the laboratory, for example. And in fact, there's a brief section towards the end of chapter 1 when I sketch out just a little bit about the environmental history of laboratories, drawing mostly upon the work of other scholars who've looked at laboratories, including, interestingly enough, my undergraduate mentor, David Kahan, who's at the University of Nebraska, where I got my undergrad degree, supervised my honors thesis, and I had no idea he had worked on physics labs and how they were organized in the context of the environment of the city until I encountered his work much later in graduate school and realized he was one of the people who had been doing an environmental history of the lab, even if he didn't call it that. Sort of material history of the lab, at least. And so I try to bring in that work a little bit in here, but this book is mainly about sciences that take place outside of the laboratory, in the field. And so in a way, it's the history of environmental sciences and the environmental history of science, both at the same time. But in taking this turn towards practice further, I'm in a way trying to make the case for a different way to slice up the history of science. So traditionally, the history of science is sliced up according to discipline. So you can study the history of biology, or the history of physics, or the history of geology, or the history of ecology, if you want to get more specific. But history is according to the disciplines themselves. Less frequently, but also a fairly common unit of analysis, is the nation state. So American science, French science, German science, British science, Chinese science, any part of the world you care to look at in a national or political context. But what I decided was to slice it up differently and to look at the commonalities of practice that were shared among different scientific disciplines. So I sort of started from scratch. Like I've got this table. See, I'm going to use the table as a prop. See, I told you could leave it up here. So I've got on the table before me now all the different examples of scientific practice. And I want to think of a way to divide up these different examples that doesn't depend on the discipline that the people came from, but that's instead based on what they're doing on the ground. And what I came up with was a 4-way taxonomy of 4 different modes of practice that account for the vast majority of the field work that was taking place in the American West during the railroad era. Now, are these 4 modes of practice, are they found elsewhere in the world? Are they found in other time periods? That remains for other scholars, perhaps me in future work, or other people to determine if these have any utility outside of my time and place. But hey, we have chalk here, so I can write them on the board, right? Oh, I might as well. There's slides coming later that show these, but the 4 modes of practice are lay networks, surveys, quarries, and field stations. And I ended up dividing up my book according to a chapter on each of these 4 modes of practice, preceded by an introductory chapter about the making of the field in general. So I'm going to go through, in the remainder of this talk, I'm going to go through each of these modes of practice and try to explain a little bit about what I think is distinctive about that mode of practice. Now notice, though, as I said, that within each of these modes of practice, you will find very different disciplines operating. So in surveys, for example, there are geological surveys, there are biological surveys, there are ethnographic surveys, there are many different, there's surveys that span the physical sciences, the life sciences, the human sciences, all the different usual divisions that we use, all done in survey mode. That is to say that they're going out with trained teams of field personnel, traversing across the land and following an itinerary and mapping out a place according to their own disciplinary content. So each of these has within it multiple different examples. Now that's not to say that every discipline has all modes of practice. So quarries are mainly in vertebrate paleontology, they're in archaeology. I make the case that they're in other, cultural anthropology has its cultural quarries too. I try to make that case. And I was kind of skating on a little bit of thin ice making that case. Just before I was ready to send in the final version of this, I came across a perfect source material that actually had somebody making the case that their cultural anthropology interviewing was like digging into digging up a fossil or an artifact. So hey, oh, there, see, they even at the time recognized the similarity in the practices here. So I did include that in the book. Anyway, where was I? What I would like to do here then is to go through each of these. But as I go through each of these 4 modes of practice, I'd like to emphasize a couple of recurring themes. So these are recurring themes that come up again in each of the modes of practice. So the first is the role of the environment. But that's not just the role of the unmediated environment in a kind of imagined kind of natural state. That is instead the envirotechnical system. So some of you may be aficionados of envirotech history, these people who blend together environmental history with the history of technology. Well, I'm taking that approach here. I'm taking that envirotech approach very consciously and deliberately. I lay that out in the introduction. This is, in some ways, what this book is an envirotechnical history of science. That's at sort of its fundamental level. It's a history of the kind of conjoined environmental and technological infrastructures and systems that undergirded the practice of science. So the railroad, for example, the railroad is the most important technology. It's so important it shows up in the title of the book, the railroad era. It defines the era, the means of transportation that people took to get into the field. Well, the railroad is a hybrid of environment and technology because you can't just put railroads anywhere. They're shaped to the landscape. They're shaped to the natural features of place. They're built to a density that fits the characteristics of the place. That is to say, if you go out in the Great Plains and Rocky Mountains, there's a lot fewer railroads per mile than if you go to the Midwest or to the South or the Northeast. So the landscape has played a huge shaping role in determining the railroad infrastructure. Now we're going to see a lot of other ways the environment plays a role, all of which are also mediated through technology. So food provisioning and subsistence in the field. Seasonality comes up, especially in the survey chapter and also in the station chapter. Seasonality turns out to be really important to the practice of science because it's a profoundly seasonal enterprise. They're not camping, and this is in Wyoming, this Hayden survey party, they're not camping in central Wyoming in the dead of winter, which would be probably pretty dangerous. They're there in the summer and the early fall. So what does that mean for the knowledge they're producing? Well, they're not seeing all the animals and plants and meteorological phenomena that might be occurring in the wintertime. And so as more people come to settle in that area, they come to make claims that the visiting scientists aren't really seeing all of nature. They're only seeing the nature that happens to be available in the time that they're traveling through. Stations, likewise, have a profoundly seasonal influence. Stations are, whether they're agricultural experiment stations, which actually cultivate crops and take care of animals on seasonal cycles, or whether they're biological field stations, where they're occupied only in the summertime for summer classes up in the mountains. They are all very seasonally operated stations because they are fit to their particular place. So I think you'll see the environment playing a role. The division of labor is the other big part of this story. And this is a division of labor on both the micro scale and the macro scale. So on the micro scale, this involves the really serious effort that I really tried hard here in this book to take account of the subordinate laborers who are part of field work. So not just the lead publishing scientist, but all the assistants, all the technicians, all the support personnel, all the cooks and packers and guides, and all a sundry group of assistants, even local collaborators who helped for a short period of time. All these people are part of this story. Now, it's of course very difficult to get source material from these perspectives oftentimes. So you have to grab onto what we can, and I grab onto every piece I could to write this book. And we'll never have as much material for all the subordinate people as we do for the lead scientists, but we can try. And the purpose of doing that is to get a picture of how the practice of science at the ground level was shaped by this micro-scale division of labor, and how simultaneously there was a hierarchy. There's a hierarchy that clearly defined everybody's role, and the cook or the packer would know their place in a way, but that there was some fluidity, that even though the hierarchy was never overturned, cooks and packers were sometimes involved in the production of knowledge. They sometimes cultivated scientific hobbies. They sometimes became adept at identifying birds, for example, or finding certain kinds of minerals. So there is a fluidity and some room for blurring of status levels, but it never overturns that status hierarchy in any of these modes of practice. And many of the people involved in these modes of practice, and this will be my other major overall point for all these different modes, which I'm going to show you pictures of shortly, is the involvement of lay people in science. Now, this has become one of the topics or themes from my work that has garnered the most interest locally when I presented this work in Arizona. So when I gave a talk at the book festival in Tucson a few weeks ago, and this is one of the major topics they were interested in, and it's because of this movement towards what's called citizen science. How many of you have heard of citizen science? Have you heard this term? It's becoming very widespread now, citizen science, the idea that non-scientists, ordinary people, could be involved in science, that they could make observations or collect things. Well, it turns out this goes all the way back to the railroad era, if not before. There have been people, they didn't call themselves citizen scientists, but there have been lay people involved in the production of knowledge in all four of the modes. Now, that's especially true of lay network, as we'll see. It's defined by its organization of lay people, but all the other modes, too, have a lot of lay people involved. And this leads to a further issue connected to that, which is that lay people oftentimes, especially if they live or work in a place for a long period of time, develop their own knowledge, which is complementary to the scientific knowledge that they may be helping to produce. So what do I mean by this? I mean the knowledge of experience. So somebody who's a hunter or a farmer in a particular area, they know where certain animals are to be found, at which times of the year. They know a lot of local details, a particular knowledge about the place. And this is a kind of knowledge I call altogether experiential knowledge in the book. Now, there's a lot of other terms other scholars have used. They've called indigenous knowledge, folk knowledge, local knowledge. If you read Jim Scott, what's he call it? Métis knowledge. There's a whole bunch of different kinds of names for something like this concept I'm using. I decided to call it experiential knowledge to make it kind of all-encompassing of all these different, in order to make it encompassing of all these different shades of meaning, but also because I want to emphasize that the knowledge of experience is grounded in something real. It's not grounded in superstition. It's not, well, sometimes could be too, but it's not necessarily grounded in superstition or error. It's grounded in actual ongoing experience. So it's grounded in something real and material. Now, the counterpart to this knowledge of experience is scientific knowledge, and the term I've adopted to refer to that as the antonym of experience, or as the complement to experiential knowledge is one I derived from one of my advisors, Rob Kohler, who calls it cosmopolitan. Now, he just, I think, issued this as kind of a throwaway term in his book, All Creatures, that the knowledge is cosmopolitan. But when I read that, I picked up on it, and I thought, exactly. That's exactly what makes scientific knowledge different from experiential knowledge. It is cosmopolitan. It travels well. It is aggregatable into larger structures of knowledge that span the globe, potentially the globe. And so what is great about scientific knowledge is its cosmopolitan character. It's not bound to local place the same way that experiential knowledge is. And so I tried to set it up as a complementary set of terms throughout the book, that knowledge could be experiential, which is great and offers something unique and distinctive, or it can be cosmopolitan, which in its own way is unique and distinctive. It's not an either or, it's a both and. They can't be encompassed one to the other. One is not superior to the other. They are complementary ways of knowing nature that coexist. And because scientists who are practicing in the field work a lot with lay people, they bump into experiential knowledge a lot. So it comes through a lot in the sources. So those are some of the major themes. Now, the final major theme I'm not going to say much about is just the larger kind of relationship of kind of regional institutions to national and global institutions, what I call in the book the macro division of labor, of cores and peripheries, which is a subject of great interest to me, but I've never been quite as successful getting other people quite as interested in it. So I'm going to kind of underplay that a little bit. But if you like core periphery type analysis, I assure you there's a lot in the book for that as well. And I am personally very interested in the relationships of sort of local and regional institutions to their core institutions, like in Washington, D.C. at the US government headquarters. Or in the American Museum of Natural History in New York City, and how they related to peripheral museums out in the American West. Okay, finally, let me get into the chapters. I've got a series, to sort of wake you up halfway through here, I've got a series of images, that some of which were used in the book, some of which weren't, to kind of liven up the discussion a little bit, to illustrate some of the points I'm making. So the first chapter in the book is a kind of introductory chapter. It's a further introductory chapter in that I'm looking at how the field as a whole was made or produced during the railroad era. So what do I mean by this? Well, I mean the envirotechnical infrastructure of the railroad system, the Transcontinental Railway, completed in the late 1860s, which opened up the region to scientific work just as it did for everything else. And in order to do this, I used two case examples to narrate the chapter, one of which is on the cover, which is Ferdinand Hayden, the US survey leader, who led one of the predecessor surveys before the US Geological Survey. He's the one who actually got aced out in the competition for directing the US Geological Survey in 1879. If you know your USGS history, Clarence King, first of all, won out over him, and then John Wesley Powell. But Hayden was the other great surveyor who was vying for that spot and lost out. But before that, he made an incredibly successful career mobilizing US government resources to take field parties right on at the very beginning of the railroad era out to the west, and he ran a gigantic enterprise of science. In fact, one of his biographers, James Cassidy, calls him an entrepreneur of science because he's so successful in this endeavor. But I use him as the narrating example of a visiting scientist. And juxtaposed to him, I have another character, TDA Cockerell, Theodore Drew Allison Cockerell, who mostly was at the University of Colorado in Boulder, although he had an earlier career in New Mexico to the south. He's an immigrant from England. He was originally British, but he made his life for health reasons in the dry American West. And he is my exemplar, because there's great archival material from him, of the resident, the person who lives in the region. And I wanted to have one visitor and one resident in order to see how the field was made for both of them in similar and different ways. And in fact, this idea of using two different narrative case studies is something I deployed throughout the whole book, which is why it ended up so long. So if you wonder, how did I end up with a 500-page book? Well, when I wrote there was originally a dissertation that was about this long, and I shortened it to half as long. And then the reviewer said I needed to put in some narrating case studies. I couldn't just do one narrating case study per chapter, because that would risk making it look like all surveying is this case study. So I decided I had to have two narrating case studies, intertwined, braided throughout the whole chapter. So every one of the chapters has two narrating case studies that you can kind of latch onto, but that are different from one another. So they illustrate some of the diversity within each category. Anyway, for the first chapter, it's Cockerell and Hayden. And I, by the end of the chapter, want to establish what the field was like as a place, in contradistinction to other places for doing science. Now, this is, of course, the most important contradistinction site, which is the laboratory. This is one of many laboratories built in the late 19th century. 1850 to 1900 was perhaps the greatest upward exponential boom in laboratory construction in all of history. Every university had to start having laboratories. This is, I think, University of Nebraska's laboratory that got advertised once they built it, their chemical laboratory. But the laboratory is the foil for all of field science, because the laboratory is the place that's the opposite of the field. The laboratory is the place that is placeless, in that the work you do there shouldn't depend on being there. You could put this lab, I said it's in Nebraska, but it shouldn't matter. It could be in Starkville. It could be in New York City. It could be in Paris. It could be in Mumbai. It could be in Tokyo. It could be anywhere in the world. You should get the same results, right? That's what laboratories are all about, is producing knowledge that is placeless. Well, the field is a place that is the opposite of that. It's a field. It's a place where place matters. Place matters in the field. We could also situate the field in relationship to the museum. Museum, of course, is a little more complicated because museums still identify places for the things in them. So museums still have the vestiges, or even more than vestiges, really important aspects of place embedded in their organization. But the museum is another place of science that could be juxtaposed that I do in this chapter, and also just kind of collections in general. This is a cabinet, I think this is a butterfly collection in Montana for Morton Elrod, the biologist up there. Okay, I want to spend the most of the time, though, on these four modes that I have remaining, going through each of them and giving just a little bit of taste of what some of the major themes are in looking at each of these modes. So the first one is a lay network. The lay network is a way of organizing people who already live in the place you want to study. Okay, so let's say I'm in Washington, D.C., and I would like to have knowledge of what's happening all across the United States. I could find people who already live in different parts of the country and get them to help me. So the idea with a lay network is, rather than trying to get all the funds to send out your own observers or your own collectors, or if you're trying to get daily weather observations, it would be prohibitively expensive to pay somebody to go out in some little town out in western Kansas to observe the weather just once a day. So instead, you enroll local lay people into your network. Now, this could be to collect things, material specimens for you, or it could be to collect data for you. And so then the trick is going to be, and I go through in the chapter so much in trying to understand, is how you could construct this network in such a way that the knowledge that comes out at the end is verifiable. And so you're going to figure out ways to manage your lay network, to structure it, to use circulars, which are these, it's an underappreciated technology. It's called the circular. They would send out the same form to everybody and ask you to fill in the blanks. How many of these did you see here? Or if it's an agricultural experiment, you send out the circulars to all the farmers who've tried the seed, and you have them fill in all the different blanks. So you structure their responses. You don't just invite them to say, how did you like this seed I sent you? How did you like it? Did you think it grew well? No, you say, what was the yield? What was the character of the head of the wheat? So you would give a very specific set of questions in order to elicit the responses that you want. Now, of course, I want to give you just a few examples of this. So in the state of Texas, there was a meteor fall. So a meteorite landed apparently somewhere around there. And they collected observations from lay people who were scattered around. Now, this is an obvious example where a lay network is really the only feasible way. You can't pre-station observers who are paid when you don't know when the meteor is going to fall. So you have to trust the observations of people who are already happen to be living or working in these different places. And then you have to plot them on a map and figure out what are the discrepancies. And what they did was, using the map techniques, they could figure out if there were anomalies that didn't fit the others, and then they could kind of see what the general tendency was on the map. Now, with agricultural experiments, this was a very common way of producing knowledge, was to station trials in all this is the northern plains, that's Montana, the two Dakotas, and Wyoming. They're seeing how it tests out in all these different locations, and each of those represents one ranch. So there's a lot of different ways to use lay networks to produce knowledge. Okay, surveys. Surveys are like lay networks covering a broad swath of terrain. They're going to be covering more than just one local place. They're going to try to map an entire territory in some way or another. But unlike a lay network where you're just relying on the people who already live there, in a survey you're sending out people. You're sending out trained staff, or more or less trained staff. Sometimes they were student workers or student undergraduates going with their college professors out on collecting trips. So their training was maybe limited to one college class maybe, but they were trained in some way, and they were under the direction of a supervisor who oftentimes traveled with them to collect and observe according to whatever their strategy was at the time. So, survey parties in the early time period relied heavily on pack animals. So even though this is the railroad era, the railroad is simply the means to get to the field, and then once you're at the railroad, it's really an animal history. So it turns out horses and mules and all these kinds of animals enter into my story quite a lot, because the field parties operating in the Rocky Mountains used a lot of pack animals, as this example from the Wheeler survey illustrates. This is the same image that's on the cover of the book. This is the Hayden survey party out in Wyoming, in kind of east central Wyoming. It's I've already given this as an example of seasonality, so I'm not going to belabor that point right here. But it could also be an example of the division of labor in the field, because all of these survey parties early on tended to have fairly large field parties. Now, over time, the field party sizes are going to shrink a lot. As people can become more self-sufficient, they can stay in hotels, they can eat in restaurants. A lot of the soil surveys in the early 20th century very rarely camped out because they no longer needed to have somebody, because there was an infrastructure now of hotels and restaurants and railroad lines. They no longer needed to hire somebody to cook for them. They could just travel in teams of two or even one person in some cases, but usually two. And so the organization of the survey parties does shift over time, but there's a lot of scope for thinking about the roles of these technicians in the field, of the cooks, the packers, the guides, the local people who assisted survey parties. And that's what I try to do in here, is show that sometimes they were actually contributing to the production of knowledge because of their side interests. Now, the characteristic knowledge product of a survey is a map. But this map is a very peculiar kind of map because this is a soil survey. This is a map of the soil surveys and where they had been done already. So they did reconnaissance scale soil surveys. They did smaller scale soil surveys. And what I'm trying to convey with this is to see how vastly different the scale could be of the survey. So the survey could be the entire western half of Nebraska, or it could be just one little spot in Lincoln County or in Hall County. And there are implications for how big the scale of the survey is in terms of how granular or not granular the map that you're going to produce is going to be. So this is a county level soil survey map, and you can see how detailed the on-the-ground mapping could possibly be in this case. Now, there are other examples in the soil survey under the USDA, which I could get into in more detail, but I'm kind of running out of time, so I think I'm not going to. But I'll just give sort of the takeaway punchline from that, and that is that when you're operating near the boundary line of the drier plains and the more humid part of the Midwest, like here in Hall County, there was a lot of interaction with locals about where these soils should be classified, and there was a lot of differences of opinion between local people who preferred that those soils be classified as more like these soils, and the national office, the National Soil Survey Office in Washington, D.C., which thought they should be classified like these soils. Now, if you're a local person there on that boundary line, you can imagine how much is riding at stake on the idea of that you are living in an arid place versus a humid place. And if you've traveled across, if you drive across the country, you know that there's no hard and fast line. It's not like one place where you say, oh, now we're in the west. It's a gradual shift. It becomes drier and drier and drier as you move west, but there's no one spot where suddenly it's dry. So they had to draw the line somewhere, and that turned out to be very locally contentious. So I'll just leave that out there as an interesting side story. Okay, number 4 is quarries. So the last two modes of practice are much more intensive, locally intensive. So these are modes of practice where you have to select a site first. So there's a procedure, a prospecting phase, for example, in quarries, where you have to look around on the landscape and find a place where there's really good stuff. Okay, and this is most prevalent in paleontology and archaeology, where you have to locate where is there a really good fossil bed, or where is there a really good quarry for archaeological remains. And then once you've found the quarry, then the task completely shifts to one of long-term, sustained exploitation of that quarry site, oftentimes with massive amounts of funding from an Eastern museum, which is willing to spend a lot of money to occupy that site for a period of oftentimes many years. So in the quarries chapter, we're looking at the intensive mining of scientific materials from the field, but crucially, and this is what distinguishes them from stations, then transporting it. So moving those materials into a museum, possibly on the East Coast or maybe even in Europe, occasionally within the West itself, and then further working with the materials in the museum or in another indoor location, as opposed to staying in the field, which is the case for stations. So quarries, you're finding extremely valuable materials, you're mining them out and taking them elsewhere. But it's a long, labor-intensive process. And this shift of this is Harold Cook at the agate fossil beds in Nebraska posing in a kind of staged photo. All of these sites, whether they're in vertebrate paleontology, as in this case, or Earl Douglas here at the Dinosaur National Park in Utah, or whether they're in archaeology, whatever the particular discipline, they are all united by a series of stages of the scientific process. So they're, first of all, they're going vertical into the earth as opposed to just picking up what's on the surface of the earth. So there's an element of verticality that enters into this mode of practice of science. But also they are prospecting, and it's in the prospecting phase of quarry science where local lay people have the most direct role to play. So in prospecting, local lay people oftentimes have a lot of knowledge about where you might find fossils. Now, it's not always perfect from the scientist's perspective. Sometimes they will spend all day following up a lead that some local person told them, and then they go there, and in one quote that I mentioned in the book, all we found was a worthless, weathered-out skull of a horse or something like that. So you don't always get the payoff that you intend, but you end up relying a lot on local people's knowledge of the terrain, of where things are. And you can't just use your knowledge of the general trend of the geological formations because there's a lot of local idiosyncrasies. So it's in the prospecting phase that local people really have their experiential knowledge come to the fore. And then local people continue to play a role in the case of land control. Now, some of the lands are public lands, some of them are not. And when they're not public lands, there can oftentimes be local landowners who have a right to give you permission or not. And so the act of securing control of the land looms larger in the quarries than in the two previous modes. Because if you're just surveying, you can travel through briefly and soil survey, geological survey, whatever it is you're doing, you're not going to have secure control of that land for a long period of time. But if you're going to be digging out a huge, in the case of Earl Douglas here at Dinosaur National Park in northeastern Utah, if you're going to be quarrying out enormous dinosaur fossils, you're going to have to get permission or secure control of the land. Now, what the Carnegie Museum does, which he works for, is they go through this weird, tortuous process of getting the US government to declare it as a national monument. Because see, how do I explain this briefly? Because they wouldn't allow them, they wanted to just put a mineral claim on the land. They wanted to use US mining law, the 1870s mining law, and say, we're claiming this land. But the US Department of the Interior would not allow fossils to count as minerals, even though they're mineralized. And so then they had to get the government to officially declare it a national monument so that no homesteader could come along and tell them they couldn't. Anyway, it's an interesting process that takes place in a lot of these cases that I try to narrate in the chapter of securing control of the land. And then, of course, there's working the quarry, hiring laborers to actually dig and dig and dig and strip away layers to get at these sometimes very gigantic scientific materials. And in some cases, like at this dinosaur quarry, they even have to start abiding by the workmen's compensation laws, the progressive era laws the state of Utah is passing for the posting of certain notices. And it's basically a work site. So even though the US government doesn't think it's a mining site, the state of Utah wants labor law to apply there. So it's a labor history story all of a sudden for all the workers there. And of course, in the end, there's the question of the local meanings. What did local people make of these artifacts or these fossil remains? Did they have their own interpretations of what they represented or what their meaning was. And that's something I conclude with at the end of this chapter, because it's a fascinating story, particularly in the case of Mesa Verde, which is my other narrating example of this chapter. Besides Earl Douglas, I look at Mesa Verde in southwestern Colorado, an archaeological site, because there's a lot of conflicts with the Ute Indians who live nearby there over the control of that land, but then it ultimately devolves into a contest over the meaning of what's there. And there's a strong view expressed by the Ute Indians that these are to be left alone, that they're basically like disturbing the graves of ancestors, and it's dangerous to go digging them up. And so there's a whole different set of meanings imposed on these fossils by Ute Indian people who live around there than the US government authorized artifact collectors. Okay, finally stations. I'll just say a few words because I'm kind of nearing the end of my 40 minutes here. But stations are the most hybrid form of field practice. And I say that because stations are partly like field sites, but they're also partly like laboratories. And occasionally they're sometimes even like museums. But they're like lab-field hybrids, because at a station, you're occupying a particular place for an extended period of time, possibly indefinitely. Many of these stations that were founded in the early 20th century are still there today. So one of the examples I look at great length in this chapter, one of my narrating case studies, is the Branch Experiment Station in North Platte, Nebraska, in western part of the state, that the Nebraska State Experiment Station set up to study the conditions of the semi-arid western half of the state. That station is still there. It was founded in 1904. It's still there today. You can still doing experiments there. So stations are places that have potentially great longevity, but where they're going to conduct work in the field for a long period of time. Now, it's not just in agricultural research, it's also in biological field stations up in the mountains, forestry stations, mining stations. There's a bunch of different kinds of stations, but agricultural stations are the predominant, most frequent form of these stations. So that's why I'm showing you this. So the first thing for a station is you have to figure out where to put it. You have to make a case for why this is a good place to put a station, why the environment is well suited, and I go through that in the chapter. But then you have to make it into a built environment. So stations have on their premises laboratories, houses. They're almost like little villages, clusters of buildings where people live, where their families live in some cases, but also places where they can conduct laboratory work on site, so they can move rapidly between lab and field. So that's why these are kind of hybrid lab-field borderland sites. Now, there's a division of labor at these field stations. There's relationships with same themes that I see throughout all the other modes of practice. There are relationships with the distant authorities. So here we have the instrument enclosure in Hays, Kansas, which is the Kansas sort of equivalent of that North Platte station in Nebraska. But they are being asked by the USDA, Office of Dryland Agriculture, to use these exact measuring instruments so that they will be recorded exactly the same way at every station across the Great Plains in order to derive more general results for the whole region and not just for the one state. And so there's a series of negotiations they have to undertake in order to figure out who is really going to be in charge of this work. Is it going to be the local people on site, or is it going to be the USDA office under E.C. Chilcott? And so that's another interesting case study that comes about. We see here somebody drawing attention to the fact that stations are all on railroad lines. They're all situated with respect to the railroad network, because a station as a hybrid site is kind of like a city. You have to supply it with materials. Very rarely, even in the ones that are up in the mountains, they preferentially put them on railway lines. So the two most prominent field stations in the railroad era in the Colorado Rockies are on the two railroad lines that go over the mountain. One is where the Moffett Tunnel is right now, where the University of Colorado Mountain Laboratory was set up. The other is the Alpine Lab, which is on Pikes Peak on the cog rail train. So they really prioritized getting access through these railroad lines. Now we might ask, as kind of a final concluding question, to leave you with a kind of thought or something to think about. In what ways does this envirotechnical infrastructure of railway lines and the ways that it's structured the practice of science, in what ways does it bias the production of knowledge in certain directions and less in other directions? So that's something to think about, is the way that it selectively sort of limits environmental perception, but that it directs and guides and channels environmental perception in some directions rather than others. And so we can think about the science that was produced in this time period as bearing the stamp of that envirotechnical system, in that they were really able to study very carefully the areas along these railway corridors, and they gained a view of nature that corresponded very closely to that. Oh, by the way, here is the mountain lab that I mentioned of the University of Colorado in the Rocky Mountains, a sort of mountain counterpart to these Great Plains agricultural stations. This is a present day picture. Well, present day, like I took it 10 years ago now. It's not really present day anymore, is it? I wonder if it looks the same now. Anyway, this is the Rocky Mountain Biological Lab in Gothic, Colorado, which is a field station I got to go visit and use their archive, which was in the back of their office. They were very kind enough to let me use it. And these sites are places, I want to leave you with this thought about that we can actually sometimes go and study because they've kept the records and files on site. We can go to the field site to study the history of field science, which is kind of rare. Only really the agate fossil beds can you do that in any of these other modes, because in all these other modes, all the data is coming elsewhere, whereas in the station, they're building up their own libraries. Here's a museum. They're building their own museum. So it's like a miniature little village there in which some of the materials can be collected and saved. Okay, so at the very end of the book, I try to chronicle what happens with the rise of the automobile in the epilogue, because the railroad era in some ways comes to an end with the rise of the automobile. Not that railroads cease to exist or cease to be important, but that now, all of a sudden, you could take, by automobile, you had much more access without worrying about food for animals. You could travel through the field much more readily. So there's going to be some changes with the automobile, other changing field practices of the 20th century. That's what I go through in the epilogue. But what I wanted to accomplish by the end of this book was to give you a sense of the modes of field practice that cross disciplinary lines, so that characterize all the field sciences. So I was looking for everything from the earth sciences to the human sciences, and I deliberately didn't limit myself to any one discipline in doing this. But I did have to limit myself regionally, and so there's an open question in the end: how much of my story is really a story about the American West, and in particular about the interior American West and about the Great Plains and Rocky Mountains? But I leave that to other scholars to follow up and find out if field practices elsewhere were similar or different. I'm trying to operate at kind of a middle scale between the local case study and grand global generalization. I decided I can't go all the way to the global, even though, like you said, I'm very interested in global history. I couldn't do that all in one project. So I wanted to get to a large enough level, the regional level, where I could start to generalize and see patterns, but the work of continuing on to the truly global level will still require further work. Thank you.
Are there questions?
I have a question.
Sure.
So, you're talking about science during the railroad era, and you spoke a lot about sort of how railroads sort of shape the location of these different roads. And I'm wondering, to what extent do you address other ways in which railroads are shaping the face of science in this time period? For example, to what extent do railroad employees themselves sort of become parts of these lay networks that you're talking about? How do they shape, perhaps financially, the research initiatives of these field stations? And do you address that in your book?
Only a little bit in the book. I actually published an article. My very first article I ever published out of this project was about that. It was called Science Along the Railroad. And it was in the Annals of Science, I think 2004. So that was my very first, well, I think I'd done it, was that my very first article? Maybe it was. I had a master's project on Alfred Russel Wallace that I did when I was over in England for my master's degree, and that ended up getting a couple articles as well, and I can't remember if one of those came first. But anyway, it was my first article about this project. And so I'm deeply interested in that problem of because railroads, and I actually have more work yet to come on that, because it turns out that in Montana, for example, the railroad companies were instrumental in funding the agricultural branch stations that were set up. They were really experiment farms across the state of Montana, were pretty much bankrolled by the railroads, which introduced all kinds. This is the Northern Pacific, the Great Northern Railroad mainly, and so they're locating them along both of those two major east-west lines through Montana. And this introduced a lot of conflicts of interest issues, because now the railroad wants to have a big say in where the station's located, what work is done there, how it's presented. And of course, the railroad has one overriding interest more than anything else, which is selling lots of land and generating a lot of ongoing traffic for their lines, maybe in that order. I mean, they're really eager to sell the land, because there's huge swaths of land that they have in those checkerboard patterns that they're trying to dispose of, but also for long-term. So the main conflict that comes about is that they are more eager to produce knowledge that will show the feasibility of farming, dryland farming in eastern Montana, whereas the agricultural scientists are a little bit more hesitant to conclude. The person who is most hesitant is E.C. Chilcott in the USDA Office of Dryland Agriculture. He says you have to wait 15 or 20 years to gather enough data to say for sure that this is a good farming system. The railroads we want it now. We want to be able to publish stuff that says it's great farmland right now. We don't want to wait 15 or 20 years to get the long-term results to see if these experiments work through all kinds of cycles of up and, because the problem is it's not in the good years, it's in the bad years. When there's drought years, can a farm sustain the drought years? Are there enough good wet years that you can have a viable operation? The people at the state level are torn. They are pulled in both directions. They have Chilcott at the USDA constantly telling them that they're not being rigorous enough scientifically, but they have the railroads who are giving all the money, saying they want more results now. And so it's an interesting, so you're absolutely right, there's a fascinating problem of the railroad's involvement. Now, actual railroad employees as lay people in networks was the other thing you asked. And that, surprisingly, there's not as much of that as you might think. Now, there's a famous example of that, which is invertebrate paleontology in the Great Fossil War between O.C. Marsh and E.D. Cope. There were a couple of guys in Wyoming who were station agents who worked for the railroad, but they were collecting fossils on the side, and they were secretly writing to... So there's an episode in the Fossil War between Marsh and Cope that involves two guys who are working for the railroad in near Como Bluff, Wyoming. And so there isn't that famous example, but I have a hard time thinking of other examples, which is really, nobody's ever asked me that before, but now that I think about it, it's a little strange. Now, in the chapter on lay networks, there is one other group of people who are well-placed early on that I do emphasize, which is the Army. The network of fortresses, the forts occupied by the U.S. Army before widespread Euro-American settlement, those forts are sort of the de facto network of possibilities for a lot of these collectors. So they work really hard to maintain connections at a lot of these within the Army. And the lucky thing for them is that Army post surgeons are oftentimes scientifically trained and are interested naturalists, are sort of amateur naturalists on the side, or maybe even publishing in some cases. And so there's sort of a ready-made group. It wasn't only the post-surgeons, but it was especially the post-surgeons who were involved in that. But it's strange that the railroad didn't generate itself, the people who worked for the railroad. Because you usually, a lot of the people, maybe it's because they traveled so much. I'm not quite sure, but that's a good question. Why weren't there more of them in this story? Other questions? Yes?
You mentioned that in your query section about how the scientists would come in and they would ask, they would sort of recruit knowledge from the various lay people about where the good fossils were and things like that. Was there any subsequent conflict over that? Because it seems like they ask around where are your cool dinosaurs, and then they take them back to New York City and leave them with nothing. And is there any sense of that this is their power, is that for the lay people, is in knowing these special places, and did they start hesitating to share this information?
Yeah, you find a kind of a wide range of reactions. So there are a lot of people who just sort of freely share, oh yeah, in the same way that you would share with other people where there's good water sources and other things. Well, I saw when I was riding the other day, this is especially in the ranching country where a lot of this is Wyoming, eastern Montana, rural Colorado, a lot of places where it's really a lot of ranchers, cowboys. I promised cowboys, right? Yeah, and actually your question, but there were exceptions, and in that article that I published in ISIS on cowboy scientists and fossils, that article was all about a conflict between a local ranching family who had started out as, the patriarch of the family started out as a cowboy, an actual literal cowboy riding north from Texas, but then he settled down, started a ranch, had a family there, and he was kind of an anomaly. Most of them didn't do this, but he really coveted being given scientific credit for finding these fossils. And he got into a long interpretive dispute with the Carnegie Museum over whether he deserved that credit or not. And he said, I want to be credited in your publications that I discovered these fossils. Whereas the museum said, well, you didn't realize their significance, or you took us to a nearby place, but we found the main fossils in a different place. So they had a long conflict over that. Now, the American Museum of Natural History that came in a few years later, they learned from that, and they played nice with the Cook family. And the Cook family repaid their generosity by giving them lots of privileged access and help. But what they basically said was to back up the Cook family's claims and say, oh yes, and they always put in their publications, and this great fossil site found by James Cook, so they gave him credit, and that really, but it seems like a lot of the local people who assisted with prospecting, sort of tips, so to speak, didn't ask for that, or sometimes they would ask for cash payment. Near Canyon City, Colorado, there's an example, a guy named Marcus Felch, who had control of a land area. He knew he didn't actually own all the land, he just knew the secret of where the stuff was, and he offered to show them where it was for a certain kind of fee payment. So he offered to sell it, sometimes they just sold it. So it was a really wide range of different reactions, which I think reveals the wide range of human motivations people have. And that there's no one story that fits for all lay people, as it turns out. Mm-hmm.
Sort of following up on the conversation you've been having about these two questions, what about the role of Native peoples and tribal land in the story? Because when you mentioned the groups that have been there before and have this kind of knowledge, you mentioned the Army, and I was thinking the entire time, well, certain groups have been there a bit longer, and I can also imagine that access gets contentious at certain sites.
And for certain types of materials. So yeah, that's a very good point, and I unfortunately never said, even though it's in the book, there are lots of examples of American Indian knowledge, and I didn't bring it out in my talk at all, and I should have not skated over that so much, because it turns out that American Indians are part of this story. Now, this is very selective, though, in terms of what parts of the story they're playing or allowed to play. So in terms of just access, the access on lands that were part of reservation lands, there was a lot of skittishness, justifiably so, for anything related to human remains or human artifacts. So archaeology and physical anthropology had to go through a lot, even back then, but way before the era of NAGPRA in more respect, people had to use subterfuge to get around it back then. But paleontology, they were more open to. So they would say, well, if you were looking for art, we want to make sure you're not looking for human artifacts, right? Okay, if you're not looking for human artifacts, but the decision in this case was made by the Indian agent. In all the cases I found, the decision was not, this is before the Indian New Deal of the 30s, this is still the era when Indian agents were imposed by the US government, and there was no real sort of sovereignty, even though that was enshrined in US law. They weren't really allowed to exercise kind of true sovereignty. So it's the Indian agent acting on behalf, saying, basically what he was saying was, well, if you're just looking for fossil bones of non-human animals, they're not going to object to that. But if you're looking for human artifacts or remains, they're going to be really mad if you do that. So I'm not going to let you do that. So it was basically the paternalistic Indian agent acting what he saw was the likely reaction of the people living on the reservation. So it wasn't like they were negotiating directly with American Indians. Now, there were American Indian guides in many cases who knew the area better than anyone else. There were people who were interested in ethnobotany, in the actual local knowledge of American Indians, that they collected it, especially ethnobotany. They collected, there were major projects to collect this kind of information, but they tended to be only in certain areas where they really were allowed to play a prominent role. So, especially in field anthropology, as interpreters, they played a huge role, and this was especially people who knew both who maybe had one parent who were of mixed ancestry, and they had one parent who was a Euro-American and one parent who was American Indian, and they spoke both languages fluently. There are several examples of that. There's also people who were American Indians who learned English and who translated and were in high demand as translators. So there were interpreters, translators, guides that played a role in some cases. But there were also people who harbored very deep prejudices against American Indians as workers. So in quarry science, around Mesa Verde, one of the original superintendents there had very, I quote them in the book because they're so striking, very strongly prejudiced views about American Indian workers, and said we don't want to hire any of them because, and he gave a whole list of stereotypical traits that he thought they had, which were of course just ethnic stereotyping to the extreme, about why they wouldn't be hired to do that work and why. But then during World War I, he ended up having to hire some of them because the labor shortage was so great. So he ended up having to go back on, I guess wartime labor shortages will do wonders for people's ethnic prejudices in some cases. But in any event, it's a very mixed story in some ways. There's instances where American Indian Participation in science was important and central. There's places where they were excluded completely. Yeah, I think it's hard to make any one generalization. In the original doctoral dissertation I wrote, I had a whole chapter about American Indian knowledge and settler knowledge, which has been deferred for another book down the road about sort of science on the frontier. And in that book, it'll get kind of treated a little bit more centrally, whereas in this book, it just sort of appears. It pops up every once in a while, but it's not the object of sustained analytical attention as it really ought to be.
Okay, well, let's thank Jeremy again.